Thanks everyone for joining this webinar today. We are going to talk a little bit about how can we make doing LCA easy. And I have the privilege to be with Dr. Haoran Lee and Dr. Randy Kirchen to show you what we have done in order to make the pavement LCA accessible for individuals. And we are very much excited to share our tool with you and the lessons that we have learned here. To start this presentation, I would like to bring your attention about the importance of the pavements in the sustainability and resilience of our built environment. We have hundreds of $billions investments in the US and we need to make sure that our investments is sustainable, meaning that it requires the minimum amount of maintenance and repair, and we can get the most out of the dollar value investments. On the other side, we are using this to purchase a lot of materials for new constructions and maintenance and repair, but we have this pavement that is not an inert material. In fact, it impacts the car fuel consumptions through the pavement vehicle interaction effects. So the surface characteristics and deflection of the pavements can influence how much fuels is going to be consumed by our trucks and cars. And also the albedo effect, which is the measure of the surface reflectance, and will give us an overview of the impact of the pavements on our adjacent buildings' energy consumption. So the environmental impact is not only the embodied emissions or environmental impact associated with the materials production, but 23 to 78% of these impacts come from the use phase and the impact of pavements on other parts of our built environment. But there is much awareness, fortunately, around including the life cycle and leveraging pavement as a solution in order to decarbonize the built environment. This is a report that I'm sharing here talking about pavement albedo as a mechanism to obtain credit in carbon market in general. So obviously, this is one part of the use phase. We have momentum around using carbonation or carbon uptake as a part of the EPDs for cement-based product. So pavement obviously is an important end-use application, and it's going to be included in the EPDs. And on the other side, more recently, the Federal Highway Administration has shaped a use stage technical subgroup to review the current methods and available tools in order to quantify the pavement vehicle interaction effects caused by the surface roughness of the pavements and also the structural performance as well. So it's great that we have this here, but the question that we receive and the space that we are facing here is that LCA is generally complex, and obviously when we move forward in time, there is a little bit of uncertainty associated with the environmental impact calculation. So how can we make LCA easier, more accessible, and also include the uncertainty to understand to what extent our robustness, our results robustness can vary from one case to another is the main question that we are tackling here. I'm going to pause here. I'm going to hand it over to Dr. Haoran Lee to walk you through the MIT solution to overcome these issues around pavement LCA. Haoran, please take it away.
Okay, thank you, Hessam. Okay, start from my part. I will start to introduce a few challenges we have been facing and the solutions from MIT CSHub's efforts. So start from the first one, as Hessam introduced. First, we observed that conducting pavement LCA is so costly and labor conservative, labor intensive. So we aim to introduce a new streamlined pavement LCA tool to make it as easier as possible for the user to implement pavement LCA, which is no more hard. And the second challenges will be two parts. The first one, for conducting pavement LCA tool, especially for the whole life cycle, we need multiple tools to perform that, including the EPD tools, LCA database, and pavement design tools even. But for here, we are introducing a new tool, which we want to integrate everything into one single tool to make it no more complex. The 2.1 challenge will be like, for implementing pavement LCA, you need a strong background, not only in LCA, but also in payment design, data collection, payment performance prediction, and also you need some expertise to interpolate the results, because a lot of the tools gives a lot of results, which may be confusing for the real decision makers. So for here, we all collect the public available data and from different sources, but also because of the source of the data include a lot of variability or uncertainty, this tool is capable to include and to embed all the uncertainties in the final decision making to make it robust and comparative results. So the third one is those uncertainty could be challenging, as we just introduced, along with our second challenging. So this one, for this two, we aim to help the decision makers, the users, any payment designers, engineers to better support their decision-making processing, which is no more less robust. So the first one, if you observe our last year's news from the MIT, so we introduced a streamlined payment framework before we construct the tool. This framework has been able to fix the first problem or the challenge, which is using this streamlined framework, we are able to develop this tool. So this tool prioritize the open source database and be able to access even there's a very little prior knowledge. We don't need that prior knowledge, which almost everyone can use this framework. And the last is the MIT CSHub Streamline tool. We're able to reduce the data collection burden by up to 85%, which means that previously the data is so intense when you're collecting data. Now we can reduce your data collecting burden up to 85%, but still help you to make the decision. And as we just introduced, so for implement the LCA tool, you need different stages using different database and different tools, EPD tools, LCA tools, LCI tools, use face modeling, and also the payment design evaluation using different softwares. So now we have embedded, integrate everything into one tool. We include from the starting from the design stage of the payment and use phase, include the performance prediction and use phase emission calculations as a whole tool within the whole life cycle. The last one, as we introduce the challenges, the uncertainties, because there's a lot of data uncertainties when we're collecting data, or the users is using the second-hand data from different resources. So here we streamline the processing by introduce the probabilistic and comparative payment LC results. So basically, this helps the decision making to make it less complicated and more robust and more confident when the users want to make decisions. Especially there are multiple payment design alternatives or different materials to compare with. Okay, so here is the streamlined framework. We always start from collecting the data or public available, the different payment contextual data, geographic data, climate data, material properties, geometry design of the payment, as well as the traffic with the significant components. So we also include the mixture design level of the material, including asphalt material, concrete material, as well as the payment design. As we're introduced, we include both actual entry and actual MEPDG design procedures. And for those one, we're able to conduct our LCA database collection as well as embodied emission calculations. Also, those initial design of the mixture, material, and pavement geometry design will impact our long-term performance, as well as the maintenance, rehabilitation, M&R. For those one, will also impact our use phase emission, including different modules of our use phase, pavement vehicle interaction, radiative forcing, and the combination of the concrete materials. So lastly, we include both embodied emission and use phase emission for the whole life cycle of pavement. So I'm very excited to introduce the beta version of the payment LCA tool from CSHub. So you can see here, we have a user-friendly interface. For the first-time users, you're welcome to introduce your username, email, and password to log in and register this tool. If you are the coming back users, you will go back to the second hand, the right-hand figure. You will just need to include your email address, which you just register, and the password. By click the sign in button, you will be promoted to the dashboard, which is step 0. It's the user's dashboard, your own case studies you have been performed. Because I'm coming back users, I have performed multiple case studies already. You can see that I named them differently for comparison, and also they can be named similarly. But more importantly, after you perform different case studies, you're also welcome, or you're able to edit the case studies you have performed. You're also able to clone, which is a copy paste of the whole case study. And also you're able to delete if you no more needed. And first time users, very welcome to start from scratch for the new experiment. Let's start from here. Okay, so for the first time users, we're starting from the first page, which is step 1, payment context. So start from here, we have the experiment name, which you can input your case study name or your project name. By doing that, I just have example, California Interstate Road example. And obviously, my current case study is for California. But all the 51 case states in the United States, we are able to analysis and we have collected all the climate data, traffic data, and all the geometry data as well. And for the details, so for this case study, I'm referring to a rural interstate case study for California example. And on the right-hand side, you can see there's a lot of qualitative inputs. But for the detail, especially for the experiment and like practical payment design, so the payment designers may need more data, especially for the traffic data. We have this button to leverage those traffic data for the implementation of payment design. For the payment designers, you will see all the traffic data are here. We have the ADT, ADTT, traffic percentage, traffic growth, track speed as well, and all in the left-hand panel. Also, because we include uncertainty in the payment LCA, not only in the LCA long-term performance, but also for the payment design. In this case, you're able to include different distribution or uncertainty of your data because you have your different inputs of the data, different data source. In this case, for each of the traffic inputs, we include uniform distribution, normal distribution, log normal distribution, which a lot of LC users are using that, triangular, and if you're just make as default, it will be uniform. And also, you're able to change all of them based on your database. You're also able to just give your different inputs, or the others will compute correspondingly. And by click this save and next, so we will be promoted to the concrete material, which is the material emission factor calculations. So again, so we're using a California case study. So that will be prop up the default California compared stress as 4,000 PSI. So we have a wide range of the PSI, and also there have a different categorical and default values. So here we give the mixture level of the concrete material, which we also divided them into different categories based on the LCA categories, LCA database. So which is A1 material, A2 transportation, and A3, which is the energy consumption related GHG emissions. So as a sum, you will be able to see the total emissions as a unit for the material emission factor. And also, if you have your own EPD data, for example, you are able to input your EPD data directly by the 3 numbers, A1, A2, A3. The program will compute that automatically for you. If you click Save and Next, you'll be promoted to the asphalt lab, asphalt mixture design, and asphalt material emission factor calculations. Also, it's California, we have the default for you already from material A1, transportation A2, energy A3. And also we include the capability for you to directly input your EPT values, A1, A2, A3. If I click the Save and Next button, so we are promoted to the payment design, include the payment geometry design, material properties, and M&R schedule. So here, all the defaults here. And for this case study, I'm implementing the concrete pavement as my design one, so which I call design one GPCP joint plane concrete pavement. I have my structure here, and also I will be able to input my own design by click the customize design part design button, because many of the designers, if they implement their own design here, they will able to do so. And just by changing the min and max at the same values, which means, okay, it is my single data points. I do not have my uncertainties in my design, but still you are able to implement these two. Material properties, as the pavement designers, engineers know, it will not only impact our pavement design thickness, and also it will affect our long-term pavement performance, cracking, faulting, and RI. So this one, you can include them by introduce the uncertainties if you have that, but also you can change that if you change that to all the same values. For example, the joint spacing, if you do not have any uncertainty of that. The M&R schedule here is the default M&R for these two, but you can see you're very welcome to include a lot of different M&R schedule and uncertainties if you have for different time and different material removal and addition for this. That is for the concrete pavement. As we just introduced, we have both actual entry and actual MEPDG designs. And also, actually, it's in the same page on the bottom, it will be our asphalt pavement design. So here I name as design 2 HMA, very similar to our concrete pavement, but obviously for the asphalt pavement, we have different pavement material properties and certainties as well, and default M&R schedule. So back-click the run design button, you will the program will show you the results, the design thickness from the program based on the actual entry or actual MEPDG. But also, if you have your own design, you don't need to click this button. You can directly click the run pavement LCA analysis to directly promote it to the LCA results. So here is the sample results for our case study. For example, we have defined our experiment name as California Interstate Road example. And we are using California State action entry for designing 20-year design life, 100 iteration. And this 100 iteration means we are running 100 multicolor simulation. We are having a lot of uncertainty already, but you're very welcome to include different numbers to promote your personal uncertainties. 50-year analysis period is set here. And as well, we can see our defined two designs name, design 1 GPCP and design 2 HMA. So here are the sample designs we have here, but also you can see that the results in the bottom. So we see a lot of uncertainties by seeing that the 95% confidence intervals. We have a lot of uncertainty start from beginning, which will be larger and larger until the end of 50 years. It is because our traffic data material properties has already included a lot of uncertainty in this case study. But when we're trying to see the mean median values in the right-hand side for the bar chart, and we can see that there's a distinguished differences between the concrete life cycle GG and the asphalt life cycle GG and different components. So for the first-time users, especially the new LCA applications, so you will see we have a few buttons here you can click on. So this helps you to understand what are they. For example, the albedo, carbon uptake, and also what are they. So we have included the information page. For example, if you click the button carbon uptake, you will be promoted this one-page information for you to understanding what is the carbonation, what is the carbon uptake in concrete pavements, and how do we calculate and how do we model that. And also, if you are pavement designers, you are more interested in the long-term performance, we also have this RI in asphalt pavement. So this one is one of the papers we published in the International Journal of Pavement Engineering, which we developed surrogate models using machine learning models for MEPDG design, which that's why we can able to run 100 iterations or 100 Monte Carlo simulation in such a very short term, because we are machine learning models accelerate that procedures. And also you will see the button indicate the detailed reports. So here you're able to see some details for concrete and the asphalt pavement, our design 1 and design 2 respectively. So for design 1, you can see that the embodied emission, as indicated in the dark gray, it is so significant in concrete pavement. But the use phase is relatively trivial compared to these embodied emissions. And for the asphalt pavement, even though embodied emissions is like about 60% of that of concrete, but its use phase emission is so significant as introduced by Hessam. The use phase emission can be from about 23% up to 87% for the pavement life cycle perspective. So this gives the indicators. And also for the last, that is the probabilistic and comparative LCA results. So if it's the first time for you to see that, don't worry. So I will introduce another case study to show how do we interpolate these results. So basically, we are comparing our concrete pavement with asphalt pavement based on our 100 Monte Carlo simulation, which is actually 100 possible futures. And for this 100 possible futures, how confident we can make the decisions? Or for this 100 features, how many of the futures concrete is win, or how many of the futures asphalt is win in terms of the environment impact perspective. Okay, so here I have a few case studies I want to share with you based on my implementation of these streamlined pavement LCA tools. So by using these tools, we have been able to perform a few case studies and a few papers we published and present in both TRB and international conference of concrete pavement last year. So the case study I want to share is the comparisons of two design alternatives for California interstate road, as we just showed the example in the previous screenshot. So for this road, we have two design alternatives, which we may very familiar with that. So for concrete, a 12-inch PCC surface layer with 1.5-inch dot bar is usually did. And for asphalt part, a 40-inch asphalt pavement is always another competitive design alternatives. So for the design perspective, we'll definitely expect that the both of the performance and long-term performance will meet the design threshold based on the MEPDG design procedure. But what about the life cycle perspective? And again, do we considering that the context, which is the impact of a material choices, and what will be the winners if we have the uncertainties already in the data? So here, as we saw that, again, in the left-hand side figure, so we saw a lot of uncertainty, especially after the maintenance schedule. But if we have the two, we're able to see that by using the probabilistic and comparative pavement LCA, we see this, the right-hand side figure gives us the distribution. And this is the distribution of the comparison indicators. So basically, we compare the 100 futures. For each futures, we select the winner. And for this specific case study, we found that the concrete pavement or the GPCP preferable is 98%. And for the asphalt, it's 2%. So which means that in the 100 possible future, there is a 98 chance concrete is the winner for this 100. And two of them is HMA is a winner. That gives the decision maker the confidence that there are 98% confidence that the concrete will be the winner, and which is over, let's say, an average statistic confidence interval, 80% or 90%. The second case study or second lessons we were conducted is for RCC, which is the roller compact concrete pavement. So as we all know, the RCC is a relatively rougher surface, concrete pavement, and also it do not has dowel bars in the transverse joints. But we all know that it could be a low carbon concrete pavement because it has a more supplementary cementitious materials, and it will be has a low embodied emissions, and but we do not know the long-term performance. For the asphalt pavement, we have a 6-inch HMA as a design alternative. So here we're analysis of Florida State Highway pavement. So for this one, yes, they're all made the design procedure or design threshold. But how do we know that which one is better in terms of the environment perspective? So here, we know that the roller compact concrete pavement, it is relatively rougher, especially like for the long-term use, it will introduce more PVI-related emissions, specifically PVI roughness. And here, we are able to use the two to compare. As you can see in the first bar chart, we call it RCC BU, business euro. It has such a large life cycle GG emissions. Significant components from the red part, which is the roughness PVI, because it's a relatively rougher surface. But do we have the chance to improve that? So because we have the tool, we are able to change the default MNR schedule. So in this case, we perform few specific analysis and case studies. And we found that the RCC with directly diamond grinding, which is the DG, after the construction, could significantly improve its life cycle GG emissions. And compared to the BU scenarios, we can see it has a 62% life cycle GG reduction. And even compared to the HMA design alternatives, we can save up to 57% life cycle GG. So in this case, our tool have helped them to improve our MNR for this RCC. And the third lesson we have learned is another case study for Massachusetts interstate highway pavement. And for this one specifically, we have a 10-inch PCC, 1.5-inch dowel bars. And for the asphalt pavement, we have 8-inch HMA layers as our design alternatives. So for comparisons, we can see that both already definitely they meet the design threshold and they meet performance. And we see that the embodied emissions for GPCP will be much higher than the asphalt pavement. But if there any chance that we can improve the design, for example, you can see that in the first bars, it's the HMA. The embodied emission, including our initial, the blue initial emissions, and the light blue MNR rate emission, it's relatively small compared to our GPCP BU scenario, business zero. But do we have the chance to improve that? So basically, this tool can help. Basically, this tool gives you the opportunity to change the pavement geometry design, specifically for concrete pavement, GPCP. We have the thickness, joint spacing, slab width, shoulder tap, etc., to improve your geometry design and also dowel bar diameters. In this case, we're able to perform a lot of case studies, sensitivity analysis, and trials and errors to see that do you have the chance to improve your design without the loss of your long-term performance. So in this case, we see that the GPCP with the improved geometry can save the life cycle GG up to 35% compared to my GPCP BU scenario. And compared to my HMA, which is another competitive design, we can save to up to 50% of the life cycle GG. Okay, so we can see that we have performed a few case studies based on the tool already, but we are seeing that a lot of lessons we have learned that from tools. So here's the takeaways. The first one, we can see that while uncertainty exists, the robust decision can still be made by using the probabilistic and comparative pavement analysis by using the tool, which is directly output from the probabilistic results. And for the second lessons, we have learned that the Streamlined tool help us to improve them in our schedules. Not only GPCP, but also RCCP, and in the future will include the CRCP, which can significantly reduce the life cycle GHG emissions by improving their use phase emissions. And also not only use phase, but also embodied emission plus the use phase. The last lesson that we have learned is the Streamlined tool facilitates the pavement design enhancement, which reducing the life cycle GHG emissions without sacrificing the performance of the pavement. Okay, so if you want to investigate more lessons, it will be best for the real users. And we're here very happy to introduce the URL of the tool, which is the http and pavementlc.mit.edu. Please feel free to copy from the, I think Andrew already shared the chat, the address. Please feel free to use that, the beta version. And we will be very happy to take up any questions from the tool and also for the future use. If you find any bugs, any recommendations, any comments, please feel free to email us, and we'll be happy to help you with the tool and also to address your issues with using the tool and for the future improvement. Thank you.
Thanks so much, Haoran. We have some questions that have been coming in the Q&A function here. Just as a reminder to everyone, if you would be so kind as to post your questions in the Q&A, and I think we've got plenty of time here to get to everyone's questions. So the first set of questions that came in, Haoran, was how would you think about applying this in other countries outside the US? Like what could it just be applied as it is? Are there things that we would need to work on to modify that? Yeah, what are some thoughts about that?
Yeah, it's a very good question. So as we introduced the LCA tool, the importance of the tool is the data collection. And the data collection, we include the climate data, geographic data, traffic data. So as long as we collect that database and we're able to perform the LCA, that is relatively easy part. The hard part is that for the designs. So if we want to include different designs and the design guide, design standardized from different countries, it will be slightly different from what we're using National and MEPG, but it's possible in the future. So we are not only streamlining the United States road network, but we can also extend the tool, maybe the next version, to a whole world or to a web application for different countries.
Yeah. I mean, folks that are interested in that, we definitely would encourage you to reach out to us because we would. Mm-hmm. So, like, let me just repeat back what I think. So, right now we've built in climate and traffic data for the US. So, we wouldn't have the ability to pre-select that. Someone could override that, I think, right, Haoran, and put in their specific version, certainly of the traffic data.
Right, exactly. Yeah.
And then we wouldn't have pre-queued up designs that would necessarily align with theirs. They could implement that though, right? They could go in and implement their own designs. So maybe as like a first pass would be that, you could use it. You would just need to, like, the default inputs would probably be less tailored for those locations outside the US. Is that a fair summary of the way you would think about it?
Right. Yeah. For the very quick use or for the different countries users, yes, just to change as much as you can to better tailor your case studies. Yeah. For the one you cannot tailor that in the future, we can talk about how to
Yeah. I think the one other thing that you didn't mention that I'm curious about your thoughts on there is the emissions factors for the materials that I should know this, but I don't. Do we currently have the ability to essentially override or change the emissions factors?
Yes, we have the ability for that, but we haven't opened the UI for the user to change that.
Okay. So that would be the other. That would probably be the other piece that I would maybe add to your list is because you may have emissions associated with specific materials may differ a bit from country to country. So that just
Yes.
So, but again, folks that are interested in that, please do reach out to us because we'd be really interested in thinking about how to make that possible. Well, also had a question about, I think I know the answer to this, but to what extent does the tool currently make use of regional calibrations for MEPDG?
Yeah. So as I introduced in the information page, so we have the machine learning model to replicate what MEPDG did. So basically, we can do all the recalibrations which the pavement ME currently can do. So for different states, if you have your own calibrations, so we can adopt that calibrations for your state and to match exactly what MEPDG gives you or pavement ME output for you.
Yeah, but maybe the flip side of that is that as it's currently implemented right now, it's essentially uses the global or sort of universal calibration factors for MEPDG.
Exactly.
But we had specifically built in there the capability to tweak that. So again, something that really be interested in working with folks on. We had a question about how do we think about the comparability or equivalence of the designs that are being compared, right? So the specific case that was given is that oftentimes an asphalt design will have more base material than a concrete design, or at least different bases. You know, in the cases that you showed, to what extent would you think of the designs as being comparable or equivalent, and like how do you evaluate that? How do you come to that conclusion?
Yeah, for currently, there's two. So one is directly from users, so we don't get that. So any user's input can be customized designs here. And the other one is using the tool to design. So basically, the output from the tool is that we meet all the design threshold. We try to meet all the, for example, the concrete pavement, RI, cracking, and faulting. And for the asphalt pavement, the rutting and RI, fatigue cracking, thermal cracking, etc. So basically, when we're designing this two pavement, all these thresholds will be met for different pavement. And we want to match exactly at the design life. So which means they're not conservative, they're not underestimate. So their design is just a red there.
Excellent. So we did have one thing I did know. There's a couple folks that have posted in the Q&A that they've gotten an error when they tried to register. So I think for those folks, I think the best thing would be for them to email us, right? And we could try to follow up with to figure out what that specific issue is. So I apologize to folks that have run into that. But we did have a clarification question about the presentation, which is what was being optimized in the geometric optimization of the JPCP design?
Yeah, very good question. So
I might interpret this as sort of what were the scope of things that could change essentially.
Oh yeah. So the scope of the optimized design will be like without changing your materials, without changing your what you already have, but change the thing you could change as a pavement designers or engineers. For example, the pavement thickness, joint spacing, slab width, shoulder tap, and base tap, and also the thickness. So by doing that, you do not change the material you already have, but you can still improve your pavement. You can still reduce lap cycle GG without sacrificing your long-term performance. That's the goal for that geometry optimization.
Excellent. And then how would you think about using this kind of a tool for composite pavements, say?
Currently, we do not have the composite pavement for the new design, but actually in the long-term maintenance in our M&R schedule, we have a different option to repair the pavement. For example, for concrete pavement, we have both concrete overlay and asphalt overlay. And for asphalt pavement, we have different. And we also have a concrete overlays. If you're specifically the composite materials, we haven't included that because they haven't had the standardized design procedures for that. But in the future, next step, we can definitely include that when it is available.
Yeah, so that addresses kind of a related question, which is, do we have the ability to analyze fiber reinforced concrete as an example? And I think the answer is right at this moment, no, because we don't have, like in the mixed design, say we don't have that as an element in it. That's some good feedback of something that would be relatively easy, I think, to accommodate. So appreciate the question from folks like that.
Yeah.
So we had what I think a really important question is, all the inputs when we start out have ranges. Actually, when you really start out, they have fairly broad ranges. Based on you having used this a number of times so far, what would you say are like the most critical things for a user to try to get more specific information about?
Yeah, that is a very good question. So actually, that also one of the lessons I've been learned by developing these tools. So for the pavement design, you definitely will say that the pavement thickness and the material, for example, the compressive strength, modular rupture, and that's for concrete. Sorry, that's for concrete pavement. Modular rupture and elastic modulus will be so significant to impact your long-term performance. Yes, it will also impact your life cycle perspective regarding to the use phase emissions. And if you're the asphalt pavement guy, yeah, definitely the surface thickness and also the asphalt air voids, like effective binder content, etc. But another important components which most of the pavement designers or engineers may have is the traffic data. It's another significant component, both impact your pavement design as well as the long-term use phase emissions. So if you want to, reduce your uncertainty, please focus on your pavement design characteristics just introduced, and also the traffic data.
Yeah, let's see. One other question, like, what are our sort of plans for integrating LCCA into this? And
yeah, that is a very good question. So as you see, the software development is relatively a little bit later than the model development. So actually, we already have the LCCA models, but it takes a few steps to really implement that in the backend, and also to change the front end, the UI UX to include that. But that will be definitely the very close next step in the next couple of months.
Yeah. So yeah, basically, I guess my restatement of that is like we already actually have the analytical elements of that, and so we're trying to get the resources to update the web interface so that you have access to that analytical capability. We had, and now just I think last, we have a question here. So we had a question about the specifics of the roughness development model. So like, does the roughness development that's used to get PVI roughness in the emissions graph come from the PMED model for roughness?
You mean this roughness, the RM model? So
yeah.
the RM model, yeah. So it is directed from the machine learning models we have developed as a surrogate models of the PMED. So basically, we doing that by accelerate that the pavement ME or MEPDG prediction, which allows us to get a lot of different features possible futures and possible IRI deteriorations for the pavement. And basically, this model is much faster than PME, but have the high accuracy or the same accurate as PME.
Yeah. Yeah. So even though AASHTO 93 might be used for the design part, when we actually do the simulation of roughness and therefore how that translates into emissions and ultimately, and then eventually cost, those are coming from those surrogate models that are based on pavement. Yeah. Excellent. And then I think we have questions keep rolling in here. I do want to address an earlier one. Our intent is to keep the tool for free access. That's clearly our intent. I mean, there are a fair amount of resources required to make it possible, but that's certainly our intent right now. Could we use this tool to compare specific concrete pavement design features like a 1 1/4 versus a 1.5 inch dowel, and how that would impact? Could we use it for that kind of detailed question?
Yeah, definitely. So we have the concrete part. That's well. Yeah, we have the dot diameter implementation.
Yeah.
You can input your different dot bars and run twice of that.
And I think, Haoran, I've seen you show me cases where that can matter. So like
it matters.
The tool is sensitive to that level of change. And then there was an earlier question about we would be happy to work with any of the ACPA chapters to look into how we could sort of tailor this to their state specific. And then the last, well, at least the last one for now, I think Andrew's probably going to pull the plug on me here pretty soon, is in California, there's a comment that in California for concrete maintenance, they see a fair amount of essentially slab replacement. So like at 30 or 40 years, you might see 3 to 5% slab replacement. Is that something that can be captured in the tool?
Yes, absolutely. So here our M&R schedule is a default. It's relatively rougher. It's like just for the general applications. If you or any state, California or any state, for example, we did a case study for Indiana, they have a very detailed implementation of M&R. We're capable to include full depth replacement, slab replacement, diamond grinding, concrete overlay, asphalt overlay, a lot of different strategies for M&R, and all of them will impact the long-term performance and also the life cycle GHG. Yes, you are able to change that.
Excellent. Actually, I think that, am I correct in that the one that's up there, the text that kind of gets cut off there, full depth, that actually is actually about some slab replacement. It's just that unfortunately the text is longer than the text field. But yeah, okay. So I hope I got everyone's questions. We had about 20 questions, so hopefully I didn't miss anyone in there. Thanks again, Haoran, for this, and thanks to everyone for joining us. I really do want to reiterate a point that I had made, Haoran had made, which is that we wanted to get this tool out there, but we also recognize it's kind of new capabilities. So please give us. We really would love feedback on how to make this even more impactful. We're happy to work. Anyone that's interested in how to tailor this to a particular state or possibly even to other countries, we'd be happy to talk with folks about that. And so with that, I'm going to hand it back to Andrew to sort of wrap us up.
Sure. Yeah. So first, thank you to our presenters for this awesome presentation. Thank you to everyone who joined. We had an awesome turnout. We had a great discussion, and we think your feedback's really valuable. So with that said, yes, please feel free to try out the beta of the tool, whose link is in the chat. And if you encounter anything that needs fixing or anything you would suggest, please feel free to either contact Haoran or the CSHub in general. I've put those links in the chat. So this presentation is going to be put on YouTube, and we will go ahead and share the slides with you. So with that, have a great day and take care.